All right, let's continue on with this section. So this next example, this is a really good one because this one is really close to two different formats. It's close to the ln because the derivative of the denominator is 2x plus 2, and I have 2x minus 5, so it's really close. But it's also kind of close to an inverse trig function. So when it's close to both, you're going to end up with both. So here we go. Here's how we want to do it. So we're going to start by rewriting the numerator and getting what I want from that ln. I want a 2x plus 2 up there. So make it a 2x plus 2. Well, I can't just turn negative 5 into 2, but I could turn a negative 5 into 2 minus 7. So now I have the 2x plus 2 I wanted for that ln target. So now I can split the fraction, and I'm going to split it so that the 2x plus 2 is in one fraction, and then I'm going to put the negative 7 in its own, but at the same time I'm going to factor that negative 7 out to the front. So this first integral, this is now just your ln. And I don't need absolute value bars because this quantity in here is always going to be positive. Okay, so the first integral is done. Now the second one, this is where you're going to have to get that inverse tangent to come out. And we're going to have to, you guessed it, complete the square. So for the x squared plus 2x, a 1 is what completes the square. So 2 minus 1 is another 1. So now I can factor, and now it will finally give me a full solution. So that's going to be minus 7 inverse tangent or arctangent of x plus 1 plus c. Okay. Let's go ahead and we're going to go to m. Example L is pretty similar. They're both definite integrals, so let's just do m. I think this one is the more difficult of the two. Because both of them, to integrate, it's just pretty straightforward. So this one, 1 over 1 plus x squared, that's just inverse tangent of x. But we're going to integrate from negative root 3 to 0, so we have some bounds to throw in. So that's 0, and the reason why I say this one's a little bit harder than example L is because you have to remember inverse tangent of negative root 3 is negative pi over 3, not 5 pi over 3. So you have pi over 3. And then example M, we haven't had one of these yet, so I figured I might as well throw on at least one just so you can see it. It's not a function you see all the time. It's in there, but we just don't use it all that often. So this one is the one function we haven't used yet, the arcsecant. So the a is going to be 2. And then arcsecant or inverse secant of the absolute value of x all over 2 plus c. All right, so the next video will be the last one that we will have for the rest of the class, or at least the rest of the chapter. I might throw in one more just for fun.